Okay folks, here's a video for your Willamette Promise practice. This question actually is on your practice worksheet, so you can follow along and answer it as we go. This question is asking us to analyze a few different orbital diagrams and then do a few things. Identify which is incorrect, and I gave you this hint that more than one are incorrect. We have to also show the corrected electron configuration and then explain which rule it violates. So remember, we have those three electron filling rules. If you don't remember the electron filling rules, you can go back to your notes. You can watch the tutorial video on electron configurations, but they're essentially the Aufbau principle, the Pauli exclusion principle, and Hund's rule. So we'll kind of go over those, but you can watch the other videos to get a refresher on that. So we're just going to go through these and try to figure out what's wrong with them, if anything's wrong, and then fix them and explain why, if they are incorrect. Starting with the first one. So what I want to go over first is, I think the main reason students find this question difficult is just in reading the diagrams. They're written a little bit different. Remember, this is a different type of test. This is a college credit test. And so we might not be as familiar with the formatting. So I kind of just want to go over how they are formatted and how you can read this. So the first thing to understand is that it's telling you this is carbon, nitrogen, oxygen, fluorine. So the letters there, those are the chemical symbols. And then the lines here each represent orbitals. So notice the first one is a 1s, so there's one orbital. 2s also has one orbital. 2p has 3 orbitals. And remember, you can have 2 electrons in each orbital. They're using the arrows, so the up and the down represent the opposite spins. Sometimes we use the circles and lines, but a lot of times you'll see the arrows up and down. So that's kind of the basic way to read this format of question. So if we look at the first one for carbon, do you notice anything odd about this orbital diagram? Hopefully something will jump out at you, and actually just kind of gave it away when I was explaining how to read these. Hopefully you noticed this region right here looks a little bit off. Hopefully by now you are familiar and comfortable with this idea that the electrons have to have opposite spin, so one up and one down, just like it's written here. Here with them both up, that is incorrect. So this one is incorrect, so I'll circle this because that's the first thing we need to do, is identify which are incorrect. And then we need to show the corrected configuration. So I'm just going to do it on here. I'm going to say don't do that. It should be pointed down, so I'll just correct it that way. And then which rule does it violate? Well, if you look back in your notes, which of the rules says that you have to have opposite spins in your electrons? It is the Pauli exclusion principle. So I'm just going to write that here. Pauli exclusion principle. It's the one that says opposite spins. So I could even write that. All right, just a little note there. So that's the first one. Wrong because of Pauli exclusion principle. Second one is nitrogen. See if you can figure out what looks a little bit off with this one. I'll give you the hint and say it's a different rule. It's not Pauli exclusion, and it's one that a lot of students mess up very frequently. So kind of gave away that there is something wrong with this, so it is incorrect. And hopefully you noticed that the thing that's incorrect is that the electrons in the 2p sublevel are doubled up before they should be. Remember, electrons want their own room as long as they can. So this electron should not be there. It should actually be in this empty orbital instead. So you can have 1, 2, 3 half-filled orbitals before you have to double up. Okay, and which rule says that? This Hund's rule. Hund's rule says that you have to have 1 electron in each orbital before the second is added. Okay, and you might want to jot down what that means. Okay, you have some more space there. And then the next one, oxygen. Is anything wrong with this one? if you don't think anything is wrong with this one, you are probably not alone. However, if you look at it long enough, or if I tell you that there is something wrong, maybe you can figure it out. And then if you still can't figure it out, I will also tell you that oxygen here is atomic number 8. So it has 8 protons. So how many electrons, if it were neutral, how many electrons should oxygen have? Hopefully you said 8. If you look back at your electron configuration or your orbital diagram, how many electrons are shown here? 1, 2, 3, 4, 5, 6. It actually doesn't have enough electrons. So it's not breaking a rule. This is kind of a silly one, but it just doesn't have enough electrons. So if we needed to add 2 more electrons, we would need to follow Hund's rule first, and we would put 1 here, and that would give us 7 electrons, and then the 8th electron would be the pair for the first one. Okay. So which rule does it violate? Kind of a trick question. It's none of the rules, it just doesn't have enough. Kind of silly, but that's the answer. And then the last one, fluorine. See if you can figure out anything wrong there. Doesn't seem to be violating any rules. Let's double check how many electrons it should have. Fluorine is 9, so it should have 9 electrons. And we count 1, 2, 3, 4, 5, 6, 7, 8, 9. So this one looks good, and it is. It's actually the only one that's correct. So that one, you don't have to do anything, or you can say that it's already correct. But the other 3 are the ones that you need to fix and explain why they're wrong. So this is kind of a good question in that it does help you review your electron filling rules, get you familiar with those. The only one it didn't address was the Aufbau principle, which is the one that says that we have to fill the lower orbitals before we can move up to filling the higher ones. Right, so make sure you are familiar with those rules and watch the other video on electron configurations if you need a little bit of a review.